In this lesson, you'll learn how to interpret and create line plots and stem and leaf plots and analyze data using mean, median, and mode. How are line plots and averages used to make decisions? How many people do you know with the same first name? Some names are more popular than others. The table shows the list of the top 5 most popular names for boys and girls born in each decade from 1950 to 1999. To help determine which names appear most frequently, the data could be displayed graphically, because it's kind of hard to interpret without a graph. Do you learn more from the numbers in their table, or a bar graph, or perhaps a circle graph? In some cases, data can be presented using a line plot. Most line plots have a number line labeled with a scale to indicate all the data. Then an X is placed above the data point each time it occurs to represent the frequency of the data. So our first step to draw a line plot is to draw a number line. Our minimum value looks to be -2 and the maximum 11. And so we need a number line that includes both the minimum and maximum, and now we can just start making X's to represent our data. Not very interesting until they start stacking. There we go. 7, +2, 7 again, 4, 9, 0, 6, 9 again, 7 again, 2 again, 0 again, 4 again, 10 again. Oh, another 7 yet, another 6, and another 9. And hopefully I made my X's all about the same size to make it easy to compare. The Highway Patrol did a radar survey of the speeds of cars along a stretch of highway for 1 minute. The speeds in miles per hour of 20 cars that passed are listed below. Make a line plot. And now with the magic of cut and paste, we have the line plot. It includes the minimum value of 64 and the maximum value of 79. I think they may have been speeding. From the line plot, it's easy to see that the speed that occurs most frequently is 72 miles per hour. Hope it's a 75 per hour speed zone. Another way to organize and display data is by using a stem and leaf plot. In a stem and leaf plot, the greatest common place value is used for the stems. The numbers in the next greatest place value are used to form the leaves. So in example 2 from the book, the greatest value is in the tens, so 32 miles per hour would have been the stem and to the leaf. And don't forget to have a handy dandy key so you can interpret it. And we're going to quickly review a stem and leaf plot. You let the tens place be the stem, so the minimum, we went from 70 to a maximum of, I think, 132. And here's our key. So the first number in the table, 85, will be represented by 8, 5, 115, 1, 1, 5, and so on. A key is included on stem and leaf plots to indicate what the stems and leaves represent when read. You've seen those before, but have you seen a back-to-back stem and leaf plot? It can be used to compare 2 sets of data. Monique wants to compare the monthly average high temperatures of Dallas and Atlanta before she decides which city she wants to move to. The table shows the monthly high temperatures in degrees Fahrenheit for both cities. To compare the data, we can use a back-to-back stem and leaf plot. Since the data represents similar measurements, the plot will share a common stem. So the stem that's the same is the tens place. So for Atlanta, 50 is 50, but for Dallas, it'd be 54 to represent 54. What's the difference between the highest average temperatures in each city? Well, for Dallas, it's going to be 95, and Atlanta, it's going to be 88. So that's a difference of 7 degrees. Which city has the higher average temperatures? Well, it definitely looks like Dallas has got 3 different months that are in the 90s. So if her goal is to avoid the heat, she wants to avoid Dallas. When analyzing data, it is helpful to have one number that describes a set of data. Numbers known as measures of central tendency are often used to describe sets of data because they represent centralized or middle value. 3 of the most commonly used measures of central tendency are the mean, median, and mode. When you use a measure of central tendency to describe a set of data, it is important that the measure you use best represents all of the data. Extremely high and low values can often affect the mean, while not affecting the median or mode. A value with high frequency can cause the mode to be misleading. Data that is clustered with a few values separate from the cluster can cause the median to be too low or too high. Mean is the sum, which in this case would be 8.26, paying attention to our key where the decimal is, divided by the number of pieces of data we had is 15, so that's going to be approximately 5.5. Stem and leaf plot is great for finding the median because it's already organized in order from least to greatest. So I can just start counting. I now have 15 pieces of data. So if I count 1, 2, 3, 4, 5, 6, 7, the 8th one should be my median. And just to double check, if I count on the other side, I should have 7 there also. 1, 2, 3, 4, 5, 6, 7. All right. So my median is 4.8. And the mode is great from a stem and leaf plot. Most often is definitely 4.4. Well, 4.4 and 4.8 are pretty close together. So in this case, we do not want to use the mean because it is not like the others. So you could say either the mode or the median. So basically we're looking for what's the worst and don't use it. The number of electoral college votes for the 12 most populous states in the 2000 presidential election are listed below. Which measure of central tendency best represents the data? Okay, it didn't say to make a stem and leaf plot, but it's a really nice way to help organize our data. So my stems are going to be 1, 2, 3, 4, 5. And then the leaves, okay, so 21, 22, 18, I'm going to put that out here because I know I have some before it, 23, 15, 25, 14, 32, 33, oops, I skipped 13, and I skipped another 13, and 54. Okay, so I was kind of modeling for you how you could make a stem and leaf plot without having to rewrite all your data. And a good way to double check that I have my points, I'm going to count, I've got 12 pieces of data, I hope I have 12 numbers, 12 leaves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. Okay, so now to find the mean, we need to have the sum, which was 283, divided by the number of pieces of data, which was 12, which is about 23.6. The median, okay, that's going to be a little bit trickier because I have an even number of pieces of data. So 1, 2, 3, 4, 5, 6. There should be my median. I should have 1, 2, 3, 4, 5, 6 after it. So this time to do my median, I'm going to have to add those two numbers. So 21 plus 22 divided by 2 is 21.5. The mode is 13. Okay, so which is the best? Not the mode. I would probably lean towards the median because it's the middle of all three. But don't pick the mode, it's way too small. A set of numerical data can be displayed in a line plot or stem and leaf plot. A measure of central tendency represents a centralized value of the set of data. Examine each measure of central tendency to choose the one most representative of the data.